Let's find out why the derivative of cotx is equal to negative cosecant square x. These proofs are also part of exercise 3.3 institute calculus. So yeah, let's get started. Okay. So left hand side is equal to derivative of cotx, and we are trying to prove that left hand side is equal to right hand side, which is cosecant square x. Okay. Now let's go back to our memory. Trigonometry, reciprocal identities. The most useful trick we can apply here is the reverse of tan theta in the form of cos or sin x. As we know back in mind somewhere that sin x is equal, reciprocal identity of sin x is cosecant x, right? So in that syntax, gonna, instead of writing the identity of cot x which is equal to 1 over tan x, I'm going to use cosine x over sin x. And we are going to apply the quotient rule here now, which is simply what? B times, which is sin x, times derivative of a, which is cosine x, minus a, which is cosine x, times derivative of b, which is sin x, divided by b square, that means sin square x. Okay, sin x. Now the derivative of co is negative, and derivative of cosine x is sin x minus cosine x. Derivative of sin x is cosine x divided by sin square x. So multiplied with each other, negative of sin square x, negative of cosine square x. Now try to think what we are seeing now already. We already know that the trig reciprocal identity that 1 over cosecant x is sin x. And we also know that sin square x plus cosine square x is equal to 1. So what we can do here is take the negative out, and we are left with sin square x plus cosine square x divided by sin square x. Now this is simply negative sin square x plus cosine x trig Pythagorean identities is 1 over sin square x, and this is equal to negative of cosecant square x, and hence proved left hand side is equal to right hand side. I hope really that this is helping to connect the dots, and it's also a video that I made for a quick recap of trig identities and derivatives, all helping you guys out, and thanks for watching.